Now we are going to solve the problem of the counting room. So first I will write a common source which is common for every question. So the question is about you are given a map of a building and your task is to count the number of rooms. The size of the map is 10 cross 10 square. And each square is whether floor or roof. You can walk left, right, up, down through the floor. The input is the first line input has 20 n and m, the height and the width of the map. Then there are n line of m character describing the map. Each character is either floor or line. The floor is denoted by the point and the wall is denoted by the hash. Print one integer, the number of rows. So in this line of input, as you can see, the output is 3. It means there are 3 rooms is present here. Now we have to find how we get these rooms. So the first room could be from this and then going through like this. This one is our first room, which has a linkage. The second room is this one. And where will be the third one? So, let us see. Hmm, you can walk. So, actually, oh, I'm sorry, I'm counting. I'm doing counting. I'm counting. No, no. So the room could be from this point. From we are starting from here. This will be a. This will be one of the room. The other room is this one, and the other room is this. So these are our three rooms. How we can get access to it and how we can solve it in a efficient way. It is our problem that how we count the way. So we can use a great first algorithm here to find the number of rows. Actually, what we will do, we will store the unvisited empty space or unvisited room as the unvisited floor. Dot character indicates the floor. So from here, we are last we are iterating in our the complete matrix and we encounter with this point. This is our 1 comma 1 point. Then from this point we will store it in the queue and then traverse in all direction, left, right, up and down. And mark visited all the floors. The floors that we are able to reach from this point is also the part of the is also the part of this floor or also the part of the room. Like from here we can reach at this point 1 comma 2. Only this point we can reach. This is our single room. It is a basic concept from us. So what we will do, we will first uh, iterating in all over the matrix, and then if it is floor and it is unvisited, then we are iterating. Then we store it in the queue and traverse it in all directions until the queue will become empty. When the queue will become empty, we will go for the next and do the same thing. So what will be the time complexity of this approach? The time complexity is as we are iterating in all over the matrices, then the complexity will be n cross m. And we are doing this thing two times. Time when we are iterating and the second time for the queue when we insert it, we will visit only the unvisited points. Actually unvisited points. Like from here we only visited this point. We are starting from here and then visited it. Then we are pointing to it. Then we only visited this point. Then we back to our iteration. After this, after visiting this point, our queue will become empty, and then we will become. Then we will come back to our iteration. Then we will visit again and check that it is visited, so not visited again or not push in the queue. Then we will reach at this point 1 comma 2 and see that it is already visited, so not pushing to the queue. Then we will reach at the this point and we will push it into queue and mark all these points. These all the points are marked, these points are marked, this and these points are marked. So then will queue will become empty. Okay. We are doing the same thing, and when we reach this point, we'll get unvisited. So we will push into the queue, and we will visit these 2 points and mark them. And when we push into the queue, we will increase the number of rooms. So this is about the code. This is our boilerplate code or the common code for the all the questions that we I'm going to take the input in the question in comma m. Then I'm going to input the math string array of m or string math n. Then that are 0 and string is math of we don't care about the m because string can take as many as you and we will make a vector is visited which will keep vector visited nodes. Okay, so its size will be a vector in and comma 0. Initially all the nodes are unvisited in room is equal to BFS or we will do it in the we will just simply pass our method. Okay, and then count rooms print our room. So what we will do we will do BFS string node and that's our count. So, and then minus the dimension the matrix. Okay. Now what we are going to do? We are going to define the universal direction in which we can travel. Equal over -1 comma 0. It means left 1 comma 0. Sorry, it means up and it is down 0 comma -2 and 0 comma 1. Left and right. These are the positions for the now it will be a 2D vector. I will take this one. Now what we will do? We will make our visited vector. We will keep check that current cell is visited or not. If the vector is visited, whose dimensions are n comma n. Same as the matrix vector. We are writing in a matrix for intervector to be. Or we can take it as a wrap as we define the static and create it as n. Will we check if mat I and j is equal to 0. It means first we check that it is a floor and it is unvisited. It is unvisited. If it is unvisited and it is closed, we will take a cube of air in cube and push this, this cell into the cube and then uh, make another variable which will restore the number of rooms and increase our number of rooms. Then we will iterate until the until P not comes to empty. If P is not empty, so authority is equal to Q dot run. With the first element from the queue and remove it from the queue. Okay, and mark it. Okay, Now, int row is equal to 80 and 0. Our int column is equal to 4 auto step in direction. It will tell in which direction we can move. Okay, so we are taking the, yeah, not as our, it will be next row is equal to row plus of 0 and into constant etc. Okay. Now we'll check that if next to and next column doesn't these next to and next column is valid or not. If is valid means it doesn't get it will get out of the boundary. So we will double consider this next column. We will if it is valid then we will push into the queue and mark the this row and column. And one thing you also need to do is not visited. If it is not visited, only then we will push. Otherwise, right, we will do the same thing again. If it is already visited, then now meet the function who is valid. Okay, and we will take an input into row and so on. Okay, now we have to take also the so we will so is less than 0 so return equal to n or less than 0 if it is out of the left wall from equal to n. Okay, we will return false. Otherwise, reject. So this is our basic case 4, and we will run the test cases. We are waiting for return the number. So return to this. So this right. Boundary using apply CSS is fine. Uh, start from 6 and our cases it is only single test cases something single test cases and we will confidence import and check for now. No, it will take a lot of time. Why things will happen? Yes, not happen. Things will start with around just valid. Okay, we will do oh, the next thing we also do then matrix item is should also be offload. We aren't able to find let me see what is the this one. Let me check. So, oh, it will go out of the boundary. 049, 060. That is true. Input. Okay, okay. That's not taking it. Right? Can also learn how to debug it. So, output is one. Two, three. Okay, so it is all equals to one. It is valid, not visited, and match of the community is like we said, the story of one that is hmm, 01, why is it called 0 and okay, okay. Mac next to and column. Sure, fine. Let me submit it. Make sure the output is fine. Okay, where is the frequency? Research, graph, counting. Come, that's fine. On the test, something. Now, read that question once and then we will talk about the problem. Question is about you are given a map of the labyrinth and your task is to find path from start to and you can walk left, right, up and down. So the same thing, each character is floor and has the wall. There are two start and end points, and this is exactly one A and one B. The input print yes if there is a path, otherwise no. So how we will proceed? First we have to find the start coordinates of the start position and end position from the map. Okay, and then what we will do according to you? We will apply the BFS same method and check whether it is possible. Uh, and for this time, we are not iterating all over the matrix. We are simply just push the start coordinates in the queue and try to visit in all the directions in which we can move. Okay, so when coming to moving on, And when we encounter with the degree, we will suggest that yes, it's possible. Now, question arises in your mind that how we will get the path. So for this, we can use another vector, which will store the parent of every element, and we will store the direction from which we reach at that point. Like if we are reaching from this point to that point. So the parent of this coordinate store that uh, at for reaching this point we are going to in the up direction. So in this way we will store that thing. Now uh, let me check that how we store. So first intro and start. We will provide some, okay. So vector start out. On this is for and comma m, then of the map, and then wrap the 0 wrap the 0 this map of our liquid between the A. It means it is a start coordinate and start part dot first map and here it map like this is equal to B and we put and the coordinate dot reflect and get from the coordinate. Okay, fine. So we will get the start coordinate and coordinate soon if possible. Now our BFF function will tell if it is possible or not. Okay. The our BFF function current here will do all the work in the BFF. Now first we find vector plus is important for this. First important point. One coordinate we will provide now. Mm, okay. Now we take it. One. So now what we will do, we will take a vector in this in Now we will take up activities as a parent to store coordinates from which we will meet to that point. Yes, so now this instrument and created and we will not over this also so we can from one uh, initiative of right of all of these before move now simply here uh, this data that you exploit here it is okay few not push start and continuous with it is continue this new again mark actually we will okay no no now painting one not three dot entity now we will mark mhm, 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 mhm. Painting continue symbols until the last two we can start and see from the start coordinates we are traveling all the floor that we can reach from it. Now it's valid and if it's valid then what we will do? We will update the plan. First thing extension from which we will have the direction and direction. So we will give what is the parent of direction next to maximum we tell that we are going to operate the parent of row comma column will store that by which direction or by from which direction we get to it. Like we are, if we are moving from up, drastically throw the up, looking at the floor. Right? Now we have to make another function. Is coming for her. minus 1. It will go to the application. Use 1 plus 1. Mm, okay. It will go to the no and it 0 is minus 1. It will work. And the y is equal. So that's the basic thing. Now what we will do? Once the cable is empty, we will check. Vector is and what is equal to x and coordinate is 1. Mm, 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 and so on, mm, okay. So so now here is 7 of and row equals 11 is equal to third. And negative of that is at this point. So we will think no, then let me see what will it think. It will no. Capital and then wait. Other one. So first we will think yes, we can reach this point. And now one parent of n row and in column example we start and then say by string we get the path string path. So what was into parent of n row is in vector equal to parent n row is path. You will tell from this direction you will reach at down. So its direction is left. It means we are coming from the right. So what we will increase the value of n cos as its direction is equal to right. We will increase as its direction is equal to up. So we will go from the down to the so the whole of this is our path. Now we will have to print a path this side and then path. Okay, then path and no, yes, okay. So now we have to get my path or not no, next no, and not no, and we won't get first next column and then we'll wait what we will do. Let's run this code. We did real better. First point. Hmm. Oh. Okay. And the start it means our function will work fastly. Just not yet. We will come. So we will look at the plot. Yeah. Hmm. Okay, yeah. Next step of bump is correct. And let arm submitting it. Yeah.